Our lesson today is on direct variation, but before we talk about what direct variation is, let's look at this diagram I have right here. Now, I've given you 2 points, A and B, and 3 different ways to get from A to B. So let's compare these 3 routes and see if we can find which one is the most direct, okay? So let's look at A. Well, starting at A, let's look at the purple route. All right, the purple route kind of curves up and around and goes to B. All right, the red route is a straight line. It goes straight from A to B. And then the green route kind of winds and curves around to get to point B. Now, stop a minute and think which one would be the most direct. All right, if you're like me, I think that the red route is the most direct. It is getting us from point A to point B in the most efficient way. The purple route has us kind of curving around, which is going to take a little bit longer. And the green route, it really doesn't make much sense as to why there are so many loops and curves in it. So a direct variation is like this red line. If we were to graph it, it would be a straight line. That means that your x and your y values are directly proportional. In other words, it just means that the relationship between x and y is changing at a constant rate. Okay? It may be multiplied by 2 each time or multiplied by 1/4, but it's doing the same thing every time. We're not multiplying by a number and then adding something else. A direct variation can be written as an equation, and that equation's form is y equals kx. In this equation, x and y are variables. They are always going to be variables. And remember that when we write an equation that we're going to graph, x and y stand for points on a graph, okay? Because remember, you have an x-axis and a y-axis on a graph. K is where we're actually going to have a number in the equation. K is the constant of variation. When we were doing slope, this was called m. So remember, y equals mx plus b. M was the slope. Well, K is also your slope of your line, but it has another name, constant of variation. And we're going to talk about finding it a little differently than using the slope formula. Okay, let's look at this problem. Now, we're going to use the same problem here in the orange on the next 3 slides. We're just going to add a little bit more each time. And then at the end, you are going to work one out on your own to turn in during the next class for a grade. It'll just serve as your documentation that you watched this video. All right, so let's look here. It says, suppose y varies directly as x. I know that sounds grammatically incorrect, but it is written correctly. Suppose y varies directly as x and y is 72 when x is 8. The first thing you're going to do is we're going to find the constant of variation. We do that by using the formula or the equation y equals kx. We're going to plug in what we know from our problem. We know that y is 72, so we're going to replace the y with 72. And we know that x is 8. So we are going to replace x with 8. Now, I did put 8 in front of the k because the coefficient always comes before the variable. And then we solve to figure out what k is. To solve this equation, I'm going to divide both sides by 8. 72 divided by 8 is 9. So 9 is equal to k. That k is, again, the constant of variation. All right? And remember, constant of variation in a graph is the same thing as the slope. All right, now we're going to use the same problem and what we just calculated on the previous slide to write a direct variation equation. You're still using that same form, y equals kx. And you're just going to fill in the constant of variation that we solved for in the slide before. So we knew that k was 9. So we're just going to write y equals 9x. And then we could use this right here to graph it if we wanted to. All right, and the third step of this, still using this same base problem, but now we're going to find the value of x when y is 63. So same formula again. This is very important that you know. You need to know that y is equal to kx. All right, we're going to fill in with what we've been given. We know that y is 63 because it tells us right here. So we're going to replace y with 63. And then we know k. We found the value of k 2 slides ago, and that was 9. So we're going to replace k with 9. And then we just solve a one-step equation. Divide both sides by 9. 63 divided by 9 is 7, so x is 7. When y is 63, x is 7. Remember that the constant of variation is the rate at which it changes, okay? So x is being multiplied by 9 every time that changes. So we know that if y is 63, divide that by 9 to give us 7 as x. Okay, I want you to take a few minutes and try this problem on your own. Now, like I said earlier, this is for a grade, but it will not be counted for correctness, okay? You're getting basically 10 free points to prove to me that you participated in the video. Now, again, you're going to have the 3 parts of the problem. First, you're going to calculate the constant of variation. That's k, so solve for k. Then you're going to write the direct variation equation. Remember, use the k you found here. And then you're going to find the value of y when x is -4. All right, if you have any questions on how to do that, on how to do this, make sure you write those down so you'll be ready to ask those when you get in class next time. All right, have a good evening, and I'll see you next class.